factors may be quite different than someone who's not threatened by having lung cancer. So they may actually remember differently. So there's recall biases, and sometimes you can correct for those by using things that you can measure or that were measured in the past to lend some objectivity to it, but oftentimes you're stuck with recall biases. So again, those two really weaken the study design. How you measure the effect in case control studies is through something called an odds ratio. So here's our example. The same NP who noticed the series of people who had lung cancer and smoked decides to study it further, and so she sets up a case control study. Now, an odds ratio are the odds that a case has been exposed to the risk factor divided by the odds that a control has been exposed. So let's see what that looks like. You've got the outcome and the risk factor, so it may be lung cancer and smoking, and you want to look at the odds that a case has been exposed divided by the odds that a control has been exposed. So how likely have those with lung cancer, how likely are they to have been exposed compared to those without? And so when you're looking at the odds of a case having been exposed to the risk factor, then you're looking at the likelihood of those being exposed having had the risk factor compared to the likelihood of those not having been exposed. So now again, we're just looking at A and C. We're looking at those who have the outcome, and we want to compare the rate of those with the outcome who were exposed compared to the rate that weren't exposed. So if you look down below, you've got this formula, so it's A over A plus C divided by C over A plus C. So it's A plus C and those exposed compared to those not exposed. Then we look at those without the outcome, same thing. We're looking at the ratio of those exposed to those not exposed. So it's B over B plus D over D over B plus D. And you can see that you can algebraically remove these denominators because they're equivalent, so you can cross out the top and the bottom. And that leaves you with a simpler formula, A over C divided by B over D, which can be converted algebraically to AD over BC. Makes it easier to calculate. In our example, lung cancer and smoking history, then you can use these numbers. I totally made these up just to illustrate the point, but you can calculate then the odds ratio by multiplying A times D divided by B times C. In this case, that would give you an odds ratio of 58.8. And the way you would interpret this is that of those who had lung cancer in this study, they would be 58.8 times more likely to have smoked than those who did not have lung cancer. Let me repeat that. This would mean that those with lung cancer in this study were 58.8 times more likely to have smoked in the past than those who did not have lung cancer. Now, a cohort study, we're looking forward in time. We pick by the exposure and look forward in time. An example would be picking 100 smokers and 300 non-smokers and following them forward in time to see how many develop lung cancer. There are strengths. This is a higher degree of evidence than the case control study where you're looking back in time. Strengths are describing the incidence. You can get a rate out of this. You can find out how often smokers develop lung cancer. You can calculate an attributable risk, which is how much of the lung cancer is explained by the smoking. You can look at rare exposures. So if there's an outcome that you expect has rare exposures, you find people with those exposures. That's how you identify them, and then you follow them forward in time. You can also look at multiple outcomes. So if you just think about the 2x2 table and what direction you're coming at it from, in this case the exposures, and then going forward in time to the outcomes. That visual kind of helps me remember these strengths and limitations. So it's good for looking at rare exposures and multiple outcomes. There's no recall bias. That's a strength. You don't have to worry about people remembering anything because you're following it forward in time and you can measure it or get it in real time. Limitations: it is more expensive than case control. You have to follow a lot of people forward in time. It's time intensive. And it's still weak or fair evidence. It's not really an experimental design in the sense of the experimenter deciding who goes into which group. There are still selection biases. Remember, in a case control study, you wanted both groups with the outcome to be exactly the same except for the outcome. In a cohort study, you want both of the exposure groups to be exactly the same except for whether or not they have the exposure. So if you're looking at smoking, you would like those two groups to be exactly the same except for whether or not they smoke. That's difficult to do. People who smoke might have other associated behaviors, such as drinking alcohol, drinking coffee, not being as active, whatever it might be. And then there is the confounding, which we talked about. One other bias that I didn't mention is the loss to follow-up bias, which is also in cohort studies. Now there's a retrospective cohort, which is looking at data that's already there in terms of the exposure and the outcome, but it is a cohort study. You're looking at the exposure and then finding out which of those subjects who had the exposure developed the outcome. The difference is it's all been done. So, for example, the Framingham study, which is in Framingham, Massachusetts, where they looked at a community of people at a variety of exposures and outcomes, you might identify a group of those people who had an outcome measured that you're interested in. You identify them by the exposure you're interested in and follow them forward in time, not really, but then look at the outcomes that they developed later that were measured and see which ones develop those outcomes. So it's a cohort study, but it's nested in the past. All the data is there. You're just going back and looking at it. It's close to a cohort study in terms of its level of evidence, just not quite as good. And that's because you're limited to what data is already there. These are also called historical cohorts, or even TROHAWK, I've heard them called, which is cohorts spelled backwards. Mostly they're called retrospective cohorts. There are clinical trials. Then these are the strongest level of evidence. They're like a cohort study, that is, they're prospective. You follow people with a risk factor forward in time to see if they have the outcome. The key difference is that the experimenters assign these folks to groups, and it's usually done in a random fashion. An example would be that you could find 200 willing subjects who agree to be in the study, flip a coin to determine who smokes and who doesn't, and follow them prospectively to see how many in each group develop lung cancer. And this is not an ethical approach because of the other, albeit slightly weaker evidence that we have. This is something that the tobacco companies actually argued for a long time, in fact still may, that the effects that we see of lung cancer are not due to the smoking, because people have never been randomized, so they feel that it's something else that the smokers are doing that they're developing lung cancer. So this is a case where we probably will never do a randomized clinical trial, but there is enough evidence that we can be pretty darn sure, because of the consistency, the biologic plausibility, the temporal sequence, the strength of association, the dose response, etc. All of those things make us feel pretty confident that smoking does indeed cause lung cancer. We won't be randomizing anytime soon. Another example where there's never been a randomized controlled trial, to my knowledge, is Pap screening and cervical cancer, because there was just enough evidence that it was felt to be unethical to randomize people to Paps or not. Clinical trials are expensive, they're time-consuming, they're good for describing incidence and attributable risk. They're the strongest level of evidence because there's no recall or selection bias, and there's no confounders if they're randomized. Limitations are there's somewhat decreased generability. The more you control your groups, the less similar they are to the population at large. When we talk about clinical trials, we'll look at this in more detail. What are the measures for cohort and clinical trials? Relative risk, attributable risk, and number needed to treat. We'll look at those in more detail. Relative risk is the incidence in the exposed divided by the incidence in the unexposed. So it tells you how much more likely those exposed are to develop the outcome than those not exposed. Attributable risk, you subtract them. You take the incidence in the exposed, you subtract out the incidence in the unexposed. What that leaves you with is the incidence in the exposed that's attributable to that particular risk factor. And then the number needed to treat, which is just 1 over the attributable risk. So that tells you how many people need to be treated or exposed to develop one outcome, or treated to develop one effect. This is a study that illustrates some of these measures. It's a study by Dahl and Hill, published just a few years ago, on lung cancer mortality in smokers. What they found during the study period is that smokers died from lung cancer at a rate of 0.9 per 1,000 per year, and non-smokers died from lung cancer at a rate of 0.07 per 1,000 per year. This gave a relative risk, 0.9 over 0.07, of 12.86, meaning that those who smoked were 12.86 times more likely to die from lung cancer than those who didn't smoke. The attributable risk, how much of the risk is due to the risk factor, was 0.9 minus 0.07, or 0.83 per 1,000 per year. That much was due to the lung, or due to the smoking. And the number needed to harm, which is the inverse of the attributable risk, was 1,205 per year. So 1,205 people smoking for 1 year caused 1 lung cancer death. That's the end of my quick overview. Remember, in God we trust. Everyone else needs to bring data, and it's up to us to be sure it's meaningful data.
What we covered in Unit 5 is an overview of study designs. We related those designs to the postulates of causation and therefore the level of evidence that each one of them provides. We also looked at some related concepts, including a review of independent and dependent variables. We looked at reliability and validity. We looked at various biases and confounding, which is eliminated through randomization. What we'll cover in Unit 6 are case control studies, which don't provide the highest level of evidence, but they provide a surprising amount of valuable information, and sometimes they're really the best we can do because of financial or time limitations. Therefore, I like to refer to them as the house red of the research world. Actually, I didn't develop this, I got it from somewhere else, but the house red of the research world, inexpensive and utilitarian, but at times surprisingly complex and robust.
Please take a few minutes and check out the U.S. Preventive Services Task Force website. This is a wealth of information which is kept current regarding all of the preventive guidelines that they have. It's also a really good spot if you're doing some background information to see what the evidence is behind different screening interventions. It's a great place to start because they've got summaries of the research in the different areas.